Okay, so this is Unit 7, Day 7, Notes Part 2. Part 2 is the word problems. These word problems here in this section are going to be work word problems. And then there's distance, rate, and time word problems. So there's two different types of problems, word problems we're going to be going over. And I do want you to bear with me. I am just as reluctant as you are when it comes to doing word problems. I'm not a fan, but we do have to get through them. And these particular type of word problems, if you understand the process, you'll just be able to like trudge through the process. So, and they are all the same. So at first you might feel like, what am I doing? But the more you do it, the better you'll get at it. And the more you'll start to recognize that it's basically the same type of problem. Okay. So these work word problems are what you'll see on your Alex as well. So it says it takes an older computer 4 times as long to send out a company's email as it does a newer computer. So you do have, I would start to label them. So we have an older computer, okay, then we have newer, and then it's working together. So that is usually what you'll see. You'll see the older, you'll see the newer, and then together. So working together, it takes the two computers 15 minutes to send out the email. How long will it take the newer computer to send out the email on its own? So it's asking you about the newer computer, but it does tell you that together it'll take 15 minutes, okay? So how you're going to work these problems out and how you're going to make these problems into equations are very, very similar every single time you do it, okay? So it'll basically 1 over 15 is what when you're getting that, the two computers take 15 minutes, 1 minute will be 1 over 15, okay? And again, you'll just see it over and over again. And the more you do it, the better you'll get at it. But 1/15 is how much 1 minute will take. Okay, 1 over 15, because he said 15 in all. We're just taking 1 minute. And it does talk about the older computer when it says that the older computer takes 4 times as long. Okay, so with this particular one, with the newer computer, we don't know anything about it. So we're going to go ahead and put X there. 1 over X for the newer computer. But for the older computer, we know that it takes 4 times as long. So we know it's going to be 4 times whatever the newer computer takes. Okay? So this is basically the equation, and you will see this over and over and over again. That is the equation we're going to kind of work out when we solve the problem for X. So what do I have to, I'll go ahead and write this here so I'll have a little bit of room. All right. So once I have this problem, we should be able, we've been working these type of problems out over and over again. We have to find a common denominator. Okay, I would use 15 times 4 to get that common denominator. 15 times 4 is 60. So our common denominator looks like it'll be 60, and then there's an X in both, so 60X. Okay. And again, you're going to see these over and over again. So you know that 60X has to multiply by everything individually. And usually I skip this part, but I kind of want to show it this time so that you understand what's going on. So I'm multiplying 60X by every single term. So what happens here, 60 divided by 4 looks like it'll be 15. And the X is going to cancel out there. Okay, so what was left over is just 15. And then the X's cancel out there, and that's it. So it's going to be plus 60 equals, no X cancels out, but the 60 divided by 15 would become 4. So this now becomes 4. And then the X is still there, so 4X. So now that we have that, we can solve it. 60 plus 15 is 75 equals 4x, divide by 4. 75 divided by 4. And we do, it says, if you see in the problem, how long will it take the newer computer to send out the email on its own? Do not do any rounding. So we're just going to divide 75 divided by 4 and get an answer. 18.75 is our answer there. So here, 18.75, okay, that is our answer. And that's basically how long it's going to take the newer computer to send out emails on its own, 18.75 minutes. Okay, and again, I know, it doesn't seem easy now, but after doing these over and over, hopefully it will really help you to understand. It's just a process. Okay, let's look at this one. Working together, 2 pumps can drain a certain pool in 5 hours. So we already know together, okay, 5 hours, we're going to say 1/5. 1 out of 5 hours is here, 1/5. That's together. If it takes the older pump, so we have an older, and if we have an older, we probably have the newer. So it takes the older pump 15 hours. So older, 1/15, okay, to drain the pool by itself. How long will it take the newer pump to drain the pool on its own? We don't know, okay? Add those together. So we have 1/15 plus 1/x equals 1/5, okay? So let's write down the next problem. So now we have 1/15 plus 1/x equals 1/5. Okay, that's what we have there. And we're going to solve. What is our common denominator? It looks like 15 in x. 15x is our common denominator there. So now you know you're multiplying 15x times 1/15, and then you're multiplying 15x times 1/x, and then 15x times 1/5. Okay. Go ahead and simplify there. The x is left, plus, looks like the x cancel out here, 15 is left, equals 15 divided by 5 is 3. So you have 3x times 1, which is just 3x. Okay. So in this particular situation, I just subtract x from both sides so to get the x's together. 15 equals 2x. Divide by 2. Your x value here is 15 divided by 2. 7.5. So basically, it will take the newer pump 7.5 hours. And how do you know it's hours? Because that's what you're kind of working with. It says if you have 5 hours, 15 hours. So how long will it take the newer pump? 7.5 hours. Okay, when we did the work. And up top, we said it was 18.75 minutes. All right. Let's go to the next one. All right, so here it says left on together. So together, we know that it's going to be a together situation. Okay. The cold and hot water faucet of a certain bathtub takes 7 minutes to fill the tub. So 1/7. Okay. If it takes the hot water, so now we have just hot water and then cold water, probably. Okay. If it takes the hot water faucet 17 minutes to fill, hot water 1/17 plus the tub by itself, how long will it take the cold water faucet to fill the tub on its own? So we don't know what the cold is. All right. So the same setup, and as you see, the more you do it, the easier it gets in a way. But again, I wouldn't say easy, but I would say that it does get easier to set up once you've seen them over and over again. So of course we have 1/17 plus 1/x equals 1/7. okay? And we're finding that common denominator. I would say 7 times 17 is 119x. So your common denominator is 119x. So you're going to multiply 119x by each term. Okay, and simplify. So 119, 17 divided by 119 should be 7, I think. 119 divided by 7. 17 should be 7. Okay, so 7x. So 7 is left over. 7x times 1 is 7x plus the 119 stays. Sorry, the x's cancel out. So this becomes 119 times 1, which is 119, equals 119 divided by 7 is 17. And then 17x times 1 is just 17x. Okay. I'd subtract 7x from both sides. You have 119 equals 10x. And then divide by 10. X is going to be equal to probably 11.9, but 119 divided by 10 is 11.9. So 11.9, is it minutes or hours? It looks like minutes, okay? 11.9 minutes is the answer there, okay? For the cold water faucet to fill the tub. All right, so we answered that. Next, one hose can fill a small swimming pool in 90 minutes. So one hose can fill a small swimming pool in 90 minutes. A larger, so I guess it's just the hose or smaller hose, S hose, smaller hose, large hose, and of course together. Okay, again, this part is not all necessary, but I like to label them so I know what's going on. So basically one hose or the smaller hose is 90 minutes. It takes 90 minutes for that. To 1 over 90 minutes. The large hose can fill the pool in 45 minutes. So this one is 1 over 45. How long will it take the two hoses together to fill it? 1 over x. We don't know how many it will take. Okay, let's write that down. We said 1 over 90 plus 1 over 45 equals 1 over x. We don't know how long it will take them together to do it. Okay, so LCD, least common denominator, it looks like it's 90 because 45 goes into 90. So 90x. Listen, 90x is the common, the LCD. So now 90, if I multiply 90x times this, the 90s will cancel out, but the x will be left over. So x plus here 90 becomes 2 because 45 divided 90 divided by 45 is 2. And then the x is still there, so 2x would be there. The x's will cancel out here, the 90 will be left. So 90. So this becomes 3x equals 90. Divide by 3, x equals 30. Okay, so your answer there is x equals 30, which is basically 30 minutes. Okay, all right, so we have that. Those are your word problems. And now we'll move into your distance, rate, and time. And these ones are, to me, are just a mess. I struggled with these when I first started teaching, only because I hadn't seen them in a long time. But I got through them, and they aren't easy. But I believe we can do it together. Okay? All right. So there are actually two different problems going on here. The first one says, a passenger train traveled 180 miles in the same amount of time it took a freight train to do 120 miles. The rate of the freight train was 15 miles per hour slower than the rate of the passenger train. Find the rate of the passenger train. Now, I'm going to leave this one out for now. Okay, this is the problem up top is the one we're kind of working on. So what you need to know about this is distance equals rate times time. Also, if you had to get time by itself, which for these problems, you need to know how to get time by itself. How would we get the t by itself on the side by itself? We'd have to divide by r on both sides. Okay. We're getting t by itself. I'm going to divide by r. So t, which is important, is also equal to d over r. So remember that this is distance equals rate times time. If you had to look at time, time equals distance over rate. And that is an important situation that's going to happen in these problems here, okay? Both of these are important to know. So let's look at this one. This one says for the passenger, so passenger train, it traveled 180 miles. So traveling 180 miles, that's the distance. The distance is 180 miles equals, now for this particular one, it says at the same amount of time, so 180 miles, same amount of time. That's important, same amount of time, same amount of time. That's an important phrase in these type of problems because basically the time is equal to one another. We're going to come back to that. It took a freight train. So the freight train, the distance is 120 miles. So the freight train took 120 miles. The rate of the freight train was 15 miles per hour slower than the rate of the passenger train. So we're seeing that the passenger train rate, we really don't know, rate times time, but we know that the freight train was whatever the rate was minus 15 miles, okay? And then times time. Good. So what we need to do with these particular problems, and then it says, then the passenger train, find the rate of the passenger train. So we're looking for the rate, just R, okay? So in this particular situation, what we have to do and what we're going to have to do for every problem like this is get T by itself, okay? T here is going to be equal to distance, we said, which is 180, over, if we got T by itself, we just divide by R, distance over rate, okay? And then let's look at this T here. T is equal to, because we have the distance, which is 120, like we said here, the distance is 120 over rate, which is, in this case, R minus 15, okay? That is what T is equal to. So why is this same amount of time important? Because they're saying that the T's are equal to one another. It's the same amount of time. So here we're going to put 180R over R is equal to 120 over R minus 15, okay? Because it says they were equal to one another. So I would cross multiply. I'd multiply R times 120 and get 120R, okay? And then equals to 180 times R minus 15. I distribute these two. I got 120R equals 180R minus 2,700. Because I multiply 180 times 15, I got 2,700. Let me subtract 180 from both sides. And I got 60R equals negative 60, I'm sorry. Negative 60R equals negative 2,700. Because again, 120 minus 180 is negative 60. And of course, if you have the negative 60 R equals negative 2,700, divide by negative 60, you'd get R equals to negative 2,700 divided by 60, negative 60, and you get 45 miles per hour. That's what I got for that one, okay? So the rate there equals 45 miles per hour because of that, okay, when I cross multiplied. Now, instead of doing this one, I'll just go ahead and do the next word problem that is very similar, and you have to kind of set it up in the same way, okay? A rowing team rowed 50 miles going with the current, and rowed 50 miles while going with the current in the same amount of time. In the same amount of time, how important is that? As it took for the row 25 miles going against the current. The rate of the current was 2 miles per hour. Find the rate of the rowing team in still water. Same thing, distance equals rates times height, and also consequently rate times time. R times T is rate times time, and this one is time equals distance over rate. We know that to be true, okay? That's always going to be true, and we know that. So let's look at this one. So we're saying that the rowing team rowed 50 miles with the current. So we know that there's going to be a with the current situation and then against the current situation. So with the current, we said that 50 miles, that's the distance. Okay. As it took 25 miles, so 25 miles situation is against the current. The rate of the current was 2 miles per hour. Okay. So with this particular one, so we know the rate was 2 miles per hour. So it's going to be rate plus 2 with the current. And if you're against the current, you have to subtract the 2 for the rate, because now you're going against the current. So with this one, with the current, that 2 is going to help you. But if you're going against the current, it's going to be minus 2. It's going to hurt you, okay? So these are what our equations look like when you're with and against. So now that we have that, we need to solve them for time because it's the same amount of time. So we need to solve them for time to get so that they're equal, kind of like we did in the last problem. So for this one, we know that time is going to equal distance, which is 50, over the rate, which right here is R plus 2. Okay, and this time is going to be equal to 25 over, we know that the rate is R minus 2. Okay, and of course, like we said earlier, you're going to have to plug these into so that they're equal to one another because it's at the same time. So now we can cross multiply. We're going to multiply this times this. That becomes 50 times R minus 2 equals 25 times R plus 2. Go ahead and distribute. 50R minus 100 equals 25R plus 50. Okay. Go ahead, I'm going to add 100 here, subtract 25R here. So add 100 here, subtract 25R here. This now becomes what? 25R equals 150. Okay. And if you divide this by 25, R is equal to 155 by 25 is 6. Okay. So your rate is 60 miles per hour. Or 6 miles per hour, sorry. Find the rate of the rowing team in Stillwater, 6 miles per hour. All right, let's look at this one. A cyclist traveled 10 kilometers per hour faster than an inline skater. Okay, so we have a cyclist and then a skater. So we know that he's traveled 10 kilometers per hour faster than him. In the time it took the cyclist to travel 40 kilometers, so we know that 40 kilometers is the distance. The skater had gone 20 kilometers. That's the distance, because it's distance equals rate times time, and we also know what's important is time equals distance over rate, okay? So this one is going to be equal to cyclists traveled 10 kilometers per hour faster. So we know that it's going to be whatever the skater traveled is the rate time, but we know that this is going to be 10 times faster than that. Okay? We don't know about this rate, but we know that this one is 10 times faster. So now we have to get it so that T is by itself. So this one becomes T over 40 is distance. T equals distance over the rate, which is R plus 10. And this is going to be 20 over the rate, which is R. And of course, we're going to have to set them equal to one another again. 40 over R plus 10 equals 20 over rate. Go ahead and cross multiply. 40R equals 20 times R plus 10. Okay, go ahead and distribute. This becomes 40R equals 20R plus 20. Subtract 20 from both sides, 20R. And this is 20R equals 20, divide by 20. The rate is going to be equal to 1. Find the speed of the skater, 1 mile per hour. Okay, or 1 kilometer per hour, because this one is kilometers. Okay, 1 kilometer per hour. Got it? Whew, we did it. We got through the word problem. So that is it for Unit 7, Day 7 Notes Part